Bismillah ar-Rahman ar-Rahim. Welcome to our session on organized by the Water and Irrigation Research Center. In the beginning, I would like to welcome each and every one of you to our session, and I would like to thank the Academy of Scientific Research and Technology for sponsoring this session organized by the Water and Irrigation Research Council. Let me first in the beginning explain to you that the Academy has 20 specialized research councils. Those councils are very, very important platform for professional engagement, exchange of knowledge, and building new partnership. The specialized councils are mandated to develop roadmaps and initiatives in cooperation with all concerned national institutions according to the priority of the country. Among those specialized councils is the Water and Irrigation Research Council. We all realize that water is the most precious and finite resource in the world, and also especially in the arid countries like Egypt. Therefore, an integrated management approach is needed to close the gap between supply and increasing demand. Water security, which is the theme of Cairo Water Week, depends on active participation of all stakeholders for sustainable water development and management. The strategic goal of the Water and Irrigation Research Council is to assist in drafting applied and scientific water strategies through initiatives and roadmaps, and exchange knowledge to decision makers and build partnership with scientific community. Those are the members of the Water and Irrigation Research Council from different institutions and organizations, from different ministries. We have representatives from Ministry of Housing, Ministry of Water Resources and Irrigation, and also Ministry of Environmental Affairs. We have also representatives from different research institutions like the National Water Research Center, the National Research Center, and the Desert Research Center, and we have also representatives from universities like Ain Shams University, Zuwail University, and Tanta University. You can see also that a mix of senior and junior scientists forming the council. The council, in fact, developed a number of roadmaps that addresses Egypt water security, following an integrated approach towards sustainable water resources management. Those roadmaps are selected as milestones towards achieving the strategic vision of Egypt 2030. So far, the council has developed 6 roadmaps, namely on future of water desalination in Egypt, because nowadays we depend on desalinated water to close the gap between supply and demand. Also, one of the non-conventional water resources, which is the reuse of domestic wastewater, agricultural drainage water, and industrial water. It's one of the roadmaps that has been developed by the Council. A third one on rainwater harvesting. A fourth one on deep and brackish groundwater. And lately, we just finished 2 roadmaps, one on climate change and its impact on groundwater aquifer. And for the first phase, we concentrated on the northwestern coast. And last but not least, the sustainable management of sludge and septage. So today, we're going to present to you three roadmaps. The ones are highlighted in red. And the first one will be on water desalination roadmap. But before we start the technical presentation of those three maps, I would like to kindly ask all the participants and attendees to our workshop to write your question, your name, and to whom your question is addressed to in the slot that's mentioned on your screen. So we'll be able after the presentations to answer as much as we can all your questions. So please write your question and put your name as well and to whom you're addressing your question. Our first speaker to this session is Professor Dr. Hussam Shawqi. Professor Hussam Shawqi is a member of the Water and Irrigation Research Council, and he's the director of the Egyptian Desalinated Research Center of Excellence of the Desert Research Center. So I'm kindly asking Dr. Hussam to present to us the future of desalination roadmap. You have 20 minutes, Dr. Hussam.
Okay, thank you, Mr. Chairman. Good afternoon, ladies and gentlemen. We are going to present actually the roadmap of future of water desalination, which is one of the roadmaps that have been conducted by our research council. Actually, the research team of the roadmap is highlighted, and why we are presenting this roadmap actually because we are now depending a lot on the desalination. I don't know why it's keep moving. Okay. 86% of our drinking water, actually we are drinking 9.1 billion cubic meter per year. 86% of these are from surface water, 11% is from groundwater, and 3% is from the desalination. Something goes wrong. Actually, I don't know why the presentation is keep moving. Okay, I will present like that because actually something is wrong with the slideshow. So this is the desalination changed by time from 1980 to 2037. It begins with something like 30,000 cubic meter per day, and now we are 746,000 cubic meter per day, and by the year of 2037 it will be 3.5 million cubic meter per day. Actually, this number is moving very fast. When we make the first roadmap for the desalination in 2011, this number was expected to be 1.5 million cubic meter per day in 2037. And when we make our second roadmap, we were expecting or we were estimating that this number will be 2.6 million cubic meter per day. But when 1 month ago, this number actually jumped to be 8 million cubic meter per day as presented by Minister of Irrigation. And we are expecting to, in the year in 2050, to be 20 million cubic meter per day as desalination. So the number is actually going very, very fast in the desalination. Desalination plants in Egypt are varied from small desalination plant to the medium desalination plant to mega scale desalination plant. For example, in El Galala, which is 150,000 cubic meter per day, and Bor Said, which is 150 cubic meter per day, Elios 80,000 cubic meter per day. And Bor Said actually planned to be with a total capacity 250,000 cubic meter per day. El Mansoura, which is ongoing desalination plant, are 80,000 cubic meter per day. El Alamein is 150,000 cubic meter per day and planned to be as high as 400,000 cubic meter per day desalination plant. This is some example of our desalination plant and also the operation, because actually operation and maintenance of the desalination plant are varied from one location to another. So, for example, in Matruh, Remela desalination plant, which is 48,000 cubic meter per day, are operated by Matruh Company for water and wastewater. Another desalination plant, which is Elios, are operated by Red Sea Company for water and wastewater, which is 80,000 cubic meter per day, as I mentioned before. El Galala desalination plant are operated by Armed Forces Engineering Authority. And also we have some small desalination plants which is operated by renewable energy and depend on brackish groundwater. These kind of desalination plants are having on focus and having much attention in Egypt now, because you know the cost of the desalination plant depend on the salinity of water. So if you have a brackish groundwater, you will have a desalination with minimum cost rather than having the desalination of the Red or Mediterranean Sea. But of course, this type of desalination plant will always be on a small scale or even a very small scale desalination plants located in some areas. Now, moving forward to the expected total capacity of the desalination plant till 2037, Matruh, we have an existing 250,000, ongoing 42, and with a total expected to be in 2037, total of 900,000 cubic meter per day. Red Sea, nearly 400,000 cubic meter per day. North Sinai, 370, South Sinai, Ismailia, and even some governorate which is till now not depending on the desalination will be a part of the budget of the desalination plant. Even in Alexandria and Kafr al-Sheikh and the Ahliya, we will have a desalination plant. In Alexandria, for example, we will have as much as 780,000 cubic meter per day a desalination plant with a total of 3.5 million cubic meter per day in 2037. This table was before the announcement of the Minister of Irrigation that the total in 2030 will be 8 million cubic meter per day. So there are much more desalination plant will go into work before very soon. Okay, we have a desalination plant. What about the desalination tariff, which is very important in our roadmap? The cost of the construction of 1 cubic meter of the desalination plant is varied from $800 to $2,000 US dollar by cubic meter. For the mega project, the number is 800, and this number are increased by decreasing the size of the desalination plant. 25% of the construction cost of the desalination plant represent the annual operating and maintenance. Power consumption is 4 to 4.5 kilowatt hour per meter square. This is the electricity consumption. And this number can be reduced by a lot if we work with the ground or brackish water desalination plant. The number of the power consumption will be lower. 13 Egyptian pound is the cost of the cubic meter of the desalination plant tariff by the holding company of water and wastewater. The percent cost of the desalination plant, which is the percent cost of the cost sharing of the 800 US dollar. The high pressure pump represent 20%, membrane represent 15%, and the other cost is 65%. But the most important two costs of the desalination plant is the high pressure pump and the membrane, and also the membrane represent nearly 1/3 of the maintenance cost of the desalination plant. Actually, the desalination R&D in Egypt are also going parallel with the desalination being constructed. So we have a lot of ongoing research. For example, we have a newly established EDRC, which is Egyptian Desalination Research Center of Excellence. And in this center, they are conducting a lot of research concerning the R&D, and in specific with the fabrication of the membrane element. And as I mentioned, the membrane element represent 1/3 of the operation and maintenance cost of running desalination plant. And also we have Water Desalination Alliance, which is conducted also by the Academy of Scientific Research and Technology. And in this alliance, we have two main R&D groups are working in high pressure pump, and we succeed to build the first high pressure pump in Egypt, which is 200 cubic meter per day high pressure pump. And also we succeed to roll the first 4 and 8 inches RO membrane element, and we are by as the first step of the alliance, and we expected by the end of the second step to have the 4 and 8 inches RO membrane element completely fabricated in Egypt. And also we actually succeed to design and manufacture a first desalination membrane element fabrication line in Egypt. Consists of casting machine, coating machine, and rolling machines. Financing of the desalination project also was an important part of the roadmap. Most of the finance now are from the government, but also the private companies investing heavily in water infrastructure project. But till now, it is focused on mostly wastewater, but the future of the PPP, public-private partnership in desalination, expecting to be in 4 new desalination plants in El Hammam, North Coast, and along the Red Sea coastal line between Safaga and Qusair under a public-private partnership. Tender planned to be in second quarter. Is expected to be now actually this kind of the 4 desalination plant. Orascom also investing a lot in the sector of wastewater, and they are also the part of the desalination plant in El Galala, as I mentioned before, and Hassan Alam are financing in the desalination plant in the new Al Mansoura. Renewable energy also, and the use of the renewable energy in desalination plant as a power desalination plant are considering a lot of in our roadmap, because, as I mentioned, power consumption represent nearly 40 to 45% of the cost of the cubic meter of the desalination. So depending on the renewable energy is considering a lot of attention, especially with the solar PV. Some spots of the desalination plant running by the solar are found in, especially in the groundwater desalination plant and small scale desalination plant. With solar PV represent 43% actually of the renewable energy used in desalination plant. The challenges of the desalination or the financing of the desalination plant in Egypt is a lot. Among of them, the government guarantees for the contract, lack of constitutional setup to regulate the relationship between private sector and government, regularity framework in Egypt, public infrastructure readiness, water type and selling price, high energy consumption, high invest and operational cost, lack of local expertise and know-how, environmental impact and health effect. Possible solution is the increased capacity, knowledge and value added to the economy from desalination to include plant design, manufacturing and construction, create incentives to attract local business to invest in the manufacturing, designing, building and operating and local and Arab labor force feature desalination plant to attain economic sustainability, expand and support digital self-training program, set up extensive educational specialization, social partnership in desalination water treatment, and develop national plan for the use of renewable energy and reduction of energy used in desalination. Develop a comprehensive environmental legislation related to desalination, selective and representative for authorities and constructed agencies to give desalination unit license, concreted effort for all parties and bodies involved in water desalination in Egypt to develop a map of seawater desalination coastal areas, concreted for all finally, private desalination project and private developers and plant operators should be required to fully disclose the same information as a publicly owned and operated facility, encouraging the multinational desalination proposals as, for example, cross-border desalination plants in conjunction with local authorities access the availability and land and facility for environmental and economically expected desalination. Thank you very much.
Thank you very much, Dr. Hossein, for your informative presentation about the future of desalination in Egypt. In fact, you highlighted very important points regarding the current and future situation of desalination and how the desalinated water can play a vital role in closing the gap between supply and demand. I would like to add one thing to this, that the STDF, the Science and Technology Research Fund, has funded several projects on desalination based on the output of this roadmap, highlighting the different focuses and different areas that could help in adopting this technology in Egypt through the roadmap. Also helped us through the fund organized by or supported by the SCDF. Thank you very much, Dr. Hossein. Now going to move to the second roadmap, and again I would like to repeat for those who joined us during the session. I'm very glad that we have so far 51 participants. So for those who are attending our session, please, if you have any question, write your question and to whom you're addressing your question. The second roadmap we're going to present about the water reuse. And in this one, it is divided into two parts. We'll talk first about the agricultural drainage water reuse, and then the second part will be on the domestic wastewater. So I would like first to ask the first speaker for the first part, which is Dr. Safwat Abdedail. And Dr. Safwat is very well known to many of you. Dr. Safwat is the drainage expert nationally and internationally, and he's also a professor of the National Water Research Center. Dr. Safwat, you have 10 minutes, please.
Thank you very much, Dr. Challen, and good afternoon, everyone. Well, since we have one roadmap for reuse, I have only 10 minutes to quickly give the highlights about the reuse of agricultural drainage water and its roadmap. Well, because of the limitation of time, I will not go to many details. The details are in the published roadmap, but then my presentation will be limited to the highlights about drainage water in Egypt and where we are going to. Well, I think the starting point, everyone talk about new water supplies, is the deficiency between supply and the demand. We have demands exceeding supply, and the deficit is increasing every year due to population increase. In 2015, the deficit between supply and demand was 20 billion cubic meter. Expected, according to the National Water Resource Plan, in 2030 will be 27 billion cubic meters. What the country is doing about this, there are different options and different strategies. Number one is the non-conventional water reuse, which among them agricultural drainage water and treated wastewater. Desalination covered by my colleague, Dr. Hassam Shaw. The second option is rationalizing water use and increasing efficiency, and this is the most important part because user is part of those policies, not only the government, and it has different also practices to be done. The last one is increasing Egypt's share of Nile water, and everybody is aware about what the country is doing to keep and defend our share in the water resources, mainly through scaling up cooperation with the riparian countries, and second, by implementing shared projects to capture the upper Nile losses, which are tremendous and they can satisfy many of the riparian countries. Well, in our work in this roadmap, two of these practices are the most related. The one is agricultural drainage and the treated water reuse. The second one is developing and upgrading the infrastructure. As we shall see, they are a main constraint for expanding our reuse. Well, in preparing the roadmap for wastewater and the drainage reuse, we took through directions or through three axes for work. The first one, to review and evaluate the current status of in the country, and to determine the challenges and the opportunities to scale up the reuse of wastewater and treated wastewater and drainage. The second route actually is about defining opportunities of applying and use of cost-effective and energy-saving technologies. Underlying fact for all non-conventional water, they involve expenditure and high investments and requires energy to be available in order to have them done. So realizing for cost-effective energy, for saving energy saving technologies are most important. The third route for developing our roadmap was formulating an executive plan for the roadmap during the next 10 years. Well, talking about drainage, I think these maps are familiar to many of us. We have very extensive drainage network covering all the agricultural land of Egypt. The main drains only is 23,000 kilometers. Then plus the branch drains and the field drains, they will come to maybe 70,000 kilometers altogether. Then they are serving altogether total area about 8.5 million faddan. This is about all the cultivated or irrigated land in Egypt. Reuse in Egypt take two options or two modes. The first one is the official one, designed, planned, and carried out by the government by building a mixing station, taking water from main drains and pump them into canals, and this can happen at the main drain level or branch level, and it's called intermediate drainage reuse. The other option is very well known. This is a public option when farmers find a shortage of irrigation water. He, with his diesel pump at the nearest drain, pump drainage water and apply them directly to the field. So the term direct and the indirect drainage water reuse goes to these two options. Well, if we look up, the country started actually the drainage reuse policy since the 1970s. During this time, there was evolution of the quantities used reused for irrigation in Egypt. I have to mention that irrigation is or agriculture is the largest water-consuming sector, consuming about 85% of our fresh water. Well, this is just a demonstration of some of the years which between the year 2009 to 2014, and we can see that the amount of drainage water have been increasing almost to 6.5. I understand now by the year 2020 is about 7 billion cubic meters. At the end of the system, the unused drainage water flow to the sea or the northern lakes, but they are if we can compare the salt load in both the reused and the drainage water to the sea, we can see that the drainage water to the sea is much more saline. If you look into the last 2 years, 2012, 2013, and 2014, 2015, we see that become more saline as we reuse more drainage water. The geographical availability of drainage water with respect to its quality. Quality because when we use drainage water in irrigation, salinity is a major constraint, and if it gets more saline, there is less opportunity to reuse this drainage water, or we have to mix them with more fresh water to be reusable. So the more we go to the north, the more we have more saline water. Each of these areas on the map we have on the sheet is catchment of one of the main drains or branch drains, which have main drain or branch drains and a pump station to evacuate water or to mix it or to use it by mixing in irrigation canal. I want just to give more explanation to this fact because some people do not realize about the quality of drainage water. Groundwater in Egypt is more fresh towards the south part of the delta or north of Cairo, and as we get closer to the sea, it becomes more saline due to sea water intrusion. I just wanted to give this explanation again. If we just take the water balance in agriculture area, when we have irrigation, we have evapotranspiration, percolation of water. Then in the south of the delta, there are deep percolation, recharging the groundwater, and drainage will be the percolation minus the downward seepage. This is different when we go to the north. In the north, we have saline water upward seepage, which is augmented by percolation, and the drainage is a combination of the percolating water and the upward seepage. It is of higher salinity, and this can we see when we go to the drainage rate in the northern part of the delta. It is much higher than in the south, but it is of high salinity. And this would explain that the water going to the sea is not all originating from irrigation water. Part of it is from the sea and back to the sea. So the norm usually used by many of us, that too much drainage water is going to the sea, they ignore that part of it is already seawater. Second great problem for drainage water is pollution. Pollution in Egypt has become an increasing trend since the end of the 1980s and 1990s. And unfortunately, agriculture drains became the dump place for either untreated wastewater or partial treated wastewater and industrial wastewater without untreated. Also, solid waste became also a problem for many of the drains, as we see. Implications for pollution are many, and they are of social and economic impact on for Egypt. Number one, health risk, of course. Number two is environmental degradation, restriction on agricultural exports. Many of the refusal of some countries to receive Egypt agricultural products because they found some residues of some unacceptable elements in the products, and that was a great loss for our economy. Less opportunities for the drainage water of use when the objective is to close the gap, but this was made some of the main drains being eliminated or did not become usable, and we lost the opportunity to use water from such drains. The water strategy has set two scenarios for reuse of drainage water for closing the gap. The one critical value, the critical scenario is about 8.9 billion cubic meter per year in the delta area, and the optimistic one 14.15. And by considering the constraints I discussed, this norms has to be actually part of what we do for in the future. So the phases of the roadmap that I mentioned in the beginning, we consider that 2 years are required for developing and modifying national strategies, plans, laws, and institutional arrangements, and reconsider ongoing projects and programs according to the challenges and opportunities in the different geographical area of the country. The second phase is a medium phase for 5 years, and it consists of collecting and treating domestic wastewater, separating industrial wastewater from the treated wastewater, treating collected polluted drainage water, and finally effectively collect and recycle. The long term is the dream phase, which we have complete coverage of sanitation services in all urban and rural areas, and my colleague Dr. Refat will elaborate on this in the next presentation. Finally, I will say that after developing the roadmap, there new important developments took place in Egypt due to the rapid development ongoing. The first one is the irrigation modernization project under consideration by the Ministry of Irrigation, which means that on-farm irrigation will make a lot of savings. This savings means a decrease in drainage water quantities and the increase in their salinities, and thus less drainage water will be available for reuse. The second great development is also construction of giant drainage treatment plants as those in Mahsana and the end of Bahr al-Ba'r, which were highly polluted before. Those are, we heard about the commissioning of the Mahsana treatment plant very recently, and the Bahr al-Ba'r under consideration or under construction, and this will mean more drainage water will be available from drains which have been excluded in the past. Thank you very much for your attention.
Thank you very much, Dr. Safwat, for your presentation, highlighting the current and also the future situation regarding the agricultural drainage water use. We'll now move to the second part of this roadmap, dealing with the wastewater reuse, and this will be presented by Dr. Rafat Abdul Wahab. Dr. Rafat is the head of the research and development sector of the holding company for water and wastewater. Dr. Rafat, you have the floor for 10 minutes.
Can you give me the share? Thank you very much, Dr. Shadin. Do you hear me? Hello?
We can hear you, Dr. Rafat. Please.
Hear me? Dr. Shadin, do you hearing me?
Yes, Dr. Rafat, yes, we can hear you.
Thank you very much, Dr. Shadin. And in continuation with what my colleague, Professor Safwat, explained, I'm going to continue the second half of the roadmap for wastewater reuse. The outline of my presentation, quickly, I'm going to touch over 10 minutes the objective, current status, wastewater reuse project in Egypt so far, challenges and recommendation. I might also mention concerning the roadmap objective is to assess the current status, study the challenges concerning the social, economic, and environmental and institutional, and also propose a workable scenario, roles and responsibilities for wastewater reuse project.
Yes. Dr. Rafat, can you please share your presentation? We don't see it.
I share it.
It's not on the screen.
Okay now?
We can see you, but not the presentation.
Okay now?
Yes. Put it on full screen.
Okay. So the objective, shall I say again, of my presentation, the outline of my presentation is to highlight somehow the objectives, the current status, wastewater reuse, challenges and opportunities, and recommendation. The roadmap objective is to assess the current status of wastewater reuse project and study the challenges, social, economic, environmental, and institutional, and propose scenarios for the organizations that can take responsibilities and roles for wastewater reuse project. The roadmap, as we see in the front of you, is highlighting, is prepared by high committee of Academy of Science, supervised by the Professor Dr. Fatma Kwari, and the respective members from different organizations, as we see in the front of you. The content, there is more than chapters, intensive work done for wastewater reuse roadmap. Of course, when I'm talking about wastewater, I'm talking wastewater reuse and agricultural drain reuse as well. The current status of wastewater reuse in Egypt, there is three routes. Direct reuse, which directly in Upper Egypt, in Red Sea, Canal, cities, governorates, that you use wastewater from the effluent of the treatment plants. And direct reuse by mixing the wastewater, the treated wastewater partially or fully treated or even untreated to the agricultural drain. And it will be reused again especially in delta governorates. There is another route for the charge wastewater to agricultural drains into lakes and finally the sea, and we consider this quantity of wastewater as wasted, not reused. Here is, the figures for the wastewater production per year. However, the roadmap, it is not, it might get a less than that figure, but this figure is now for 2020. The number of total wastewater is 8.2 billion. The coverage of sanitation now is overall coverage for sanitation, included rural sanitation and urban sanitation, is around 65%. It means that 5.2 billion cubic meter per day per year is produced. The 0.5 billion cubic meter per year is for direct use, and 4.35 billion for indirect use in delta. And only 0.35 billion cubic meter per year is to be discharged to the sea. However, now for the recent consideration of the Mahsana drain, Bahr Fakar drain, this figure is under consideration to be reused again. I want to say from this figure that there is more wastewater is reused more than one time in delta, and the strategy for wastewater reuse in Egypt is taking into consideration, and it's high in the agenda of the government. However, the roadmap highlighted in the quality of the wastewater itself, easier mixed with drain or treated wastewater from the treatment plant. The roadmap highlighted as well on the code, the new code for wastewater reuse, highlighted in the degree of treatment, specifying the crops, irrigation methods, public health consideration, and also the monitoring system. Also, the roadmap, because of this new code for Egypt, and it is very important to consider it and to see how we can improve this code in the future. The roadmap highlighted as well on the degree of treatment on 4 degrees, starting from primary till advanced. The current status of wastewater reuse project map, as you see on the front of you, we have projects all over the Egyptian governorates for wastewater application. However, still somehow we need to highlight in some areas available, and some water are available are not optimizing in using. Here is in some the current wastewater reuse project in governorates, in Asyut, in Red Sea, Kenya, and Suad, and Luxor. What is the challenge? This is very important that we discussed over, let's say, even 1.5 years for roadmap, the challenge facing wastewater reuse. As I explained to you, wastewater goes in two directions. Either directly, I'm speaking about industry now, directly to the wastewater through the force main or to the drain, and in both cases, industry affecting the viability and the replicability of some wastewater reuse projects. We have in Egypt more than 60 wastewater treatment plants received industrial wastewater, because as you know that industrial wastewater is mixed with domestic wastewater to the treatment plants. The map highlighted in this part by developing a special strategy or a special vision for reusing of such wastewater in these treatment plants, especially in these treatment plants in the government. I must also highlight, about the compliance action plan, the compliance of different sectors. This is really embarrassing because you see, I must say the compliance is not in a good shape, and this is due to the lack of enforcing of the law. The second challenge, which is really important, and this is from my point of view as a holding company, is the outcomes of this roadmap is to establish or to solve what we're calling institutional entanglement, اللي هي التشابكات المؤسسية. As you know, wastewater reuse project and land allocation is belonging to nine different organizations and ministries. This is really the main challenge facing wastewater reuse in Egypt, and because of the limited of the time, I just highlighted the recommendation given by the roadmap to solve such a challenge by unifying the responsible organization to tackle such challenges. There is other challenges and it has been mentioned by Professor Dr. Safwat Abdeldaim for the low coverage. However, Ministry of Housing now is tackling that problems. There is a lot of problems now with World Bank, with CWW, with EU, and with others to cover the rural sanitation, to cover the village with rural sanitation services. Solid waste is very important, and it is not high on the agenda so far, and this is one of also the outcomes of the roadmap to see how we can solve the problems, because it pollutes the drain for indirect reuse. If you look at the Kafr al-Sheikh and Menufia and this governorate in Upper Egypt, in Delta, they rely on direct reuse. So even if we go for full treatment of domestic wastewater, solid waste will affect tremendously the plan for reuse. Lack of comprehensive vision and sectorial coordination is very important, and it has to be coordinated together. One of the very important issue as well, it's mentioned, but it's not highlighted actually in the roadmap, the social acceptance of irrigating crop waste treated wastewater. This is also one of the challenges. The roadmap recommended offers very important recommendation, and it has been mentioned somehow untouched by Dr. Safwat, the reconsidering of industrial wastewater disposal system, whereas in terms of treatment, governing law or administrative liability. Also reconsidering the current situation system and law governing for reuse. The institutional framework is very important and need to be solved and be highlighted. And I think it's under consideration by the Ministry of Housing so far. Conducting studies for long-term impact of wastewater reuse, social, environmental consequences. This is also need to be considered, and it has been highlighted by the roadmap. I want to say that there is a lot to say about the roadmap, but due to the limited time, I'm just picking up the most important point. Thank you very much for your attention.
Thank you, Dr. Rafat, for your presentation, and I would like to assure all the attendees that the roadmaps are available on the site of the Academy, so you can have a look at those roadmaps in more details, because we have only limited time to present, the output of all roadmaps. Thank you again, and then we'll move to our last speaker. We'll talk about the sustainable management of sludge and septage, and this will be presented by our eminent professor, Dr. Fatma Al-Bohari. She's the professor at the National Research Center and an expert in water quality. Dr. Fatma, you have the floor for 20 minutes. And again, I would like to ask the participants, if you have any questions, please write down your question.
Dr. Challen.
Yes, Dr. Fatma.
Can you hear me?
Yes, we can hear you.
Okay, thank you, Dr. Challen. Is the presentation?
It is available on the screen. Yes, you can go ahead.
Thank you, Dr. Challen. I am going to talk about the problem in Egypt, and this is the disposal, treatment and disposal of sludge and septage in Egypt. The sludge is the solid part which is produced from the treatment of wastewater, either from centralized treatment facilities or on-site sanitation. This activity is carried out by the holding company and its 25 branches, by the by the Cairo and Alexandria Potable Water Organization, by NOPWAS, and the regulatory agency. All these entities belong to the Ministry of Housing and Urban Development. These are some basic figures on the sanitation situation in Egypt. It is well known, so I'll skip it. The sanitation services in Egypt have been improved tremendously during the 5 last decades. We have to admit that a lot has been done in this sector, either for safe drinking water and proper sanitation systems. However, most of these projects were focused on large infrastructure and centralized wastewater treatment facilities in big cities. If we look to this figure, we can see that most of the treatment facilities are medium and small size treatment plants. We apply here all the technologies known for wastewater treatment, ranging from activated sludge to oxidation ponds. But in Egypt, about 66% of the wastewater treatment plants are centralized activated sludge-based treatment plants. Why I am saying that? Because the sludge produced depends on the type of treatment, the efficiency of treatment, and different factors. This is a schematic diagram of a conventional treatment plant, starting from raw sewage implementation to biological treatment and disinfection, and then the sludge produced is dried in drying beds. And this type also, it is a schematic diagram of the biological treatment, whether it is suspended growth or fixed film. And the third type is anaerobic treatment. In the anaerobic treatment, there is no primary treatment. It is only anaerobic biological treatment. And this type of treatment is considered advanced primary treatment. This shows us the comprehensive treatment, including aerobic, anoxic, and anaerobic treatment. And this shows us the sludge produced from the different steps of treatment, primary sludge, and then the secondary sludge goes to the thickener to increase the solids content, and then to sludge digesters, and after which it is the water either rejected or reused. This is the sludge part. As I mentioned before, sludge production has been, or sludge treatment has been neglected. Although, why? Because it is very expensive. It accounts for 30 to 40% of the capital cost and around 50% of the operating cost. The quantity of the sludge depends on the quality of the incoming wastewater, the volume, and the composition. The type of wastewater treatment technology used also produces different types and different quantities of sludge. The treatment efficiency. These treatment facilities in Egypt produce now 3 million tons of dry solids annually. The majority of wastewater treatment plants lack efficient treatment for sludge, so about 85% of non-stabilized sludge is improperly disposed and directly used for agricultural purposes. We have to mention here that sludge accumulates the pathogens in the wastewater and also the organic and inorganic pollutants. This part of solids in the sludge is around 1%, the rest is water, and the solids 20 to 40% is organic in nature and 60 to 80% organic. This represents a biological treatment system with aeration, which is very expensive. This is the most expensive part of the biological treatment. The aerobic biological treatment consumes a lot of energy. And this is the drying beds from the, this is the anaerobic digestion. Here we can see the daily sludge production. I mentioned that most of the treatment facilities are small or medium sized, but when we come to the quantity of wastewater treated, then the central treatment facilities in Cairo, Giza, and Alexandria produce the highest quantity of sludge because they treat the highest quantity of wastewater. This is the distribution of production of sludge in Egypt. And here we can see that the sludge contains organic matter ranging from 40 to 70%. This range depends on the factors I already mentioned. Total nitrogen, which is very important for the agricultural, 0.5 to 1 point, phosphorus also, and potassium. These are nutrients very important to agriculture. The sludge management in Egypt is not as it should be, and this is due to lack of financial resources, because it is a very expensive part of the whole treatment. And even in the areas where it is dry, there is no enough land area available near the treatment facilities to allow for the sludge to be dried as it should be. So sludge is not treated properly. The common technologies or techniques for sludge treatment starts with sludge thickening to increase the solid part. This is gravity thickener. For drying beds, natural dewatering, natural drying. This represents the aerobic wastewater treatment. It requires energy to produce sludge. Sludge can produce energy, then we can optimize the cycle. These are digesters, anaerobic digesters for sludge, different types. Digestion is carried here devoid of oxygen, no oxygen. It produces gas, which methane gas, which can be used as converted to electricity and used for the operation of the sewage treatment facility. These are different types. The after sludge treatment, sludge has to be dewatered to increase the solids content from 25 to 35, and then the mechanical decanters can be used, or belt filters, chamber filter presses. This has been already mentioned by Dr. Refat. Luckily, the analysis of the sludge in Egypt indicated that the heavy metals did not exceed the limits for sludge use for agricultural purposes. Here in Egypt, we have successful case studies for sludge disposal, anaerobic digestion. This has been started in Jabal al-Asfar, and wind row composting already in site 9N in Alexandria Governorate, co-composting of sludge in Sakha in Kafr al-Sheikh, sludge stabilization using storage lagoons has been implemented in Abu Rawash. This is Jabal al-Asfar sewage sludge treatment. The sludge stabilization using windrow composting. The sludge is transferred to an area prepared for the co-digestion, for the composting operation. The raw undigested sludge is aerated, mixed using these facilities until it is dried. This process increases the temperature to 60 degrees centigrade, and this kills most of the pathogens in the sludge. The anaerobic co-digestion of sludge, this is done now in Sakha, and it is operated by the private sector. Sludge is co-digested with food wastes and the organic part of the garbage. This is Kafr al-Sheikh, Sakha. The digester. Another option is to digest sludge in storage lagoons, and this is carried out in Abu Rawash now. The sludge produced from Zenin wastewater treatment plant is transferred primary and secondary sludge to Abu Rawash, mixed with the primary sludge of Abu Rawash and goes to the lagoon there, where it kept for years until it is mineralized. This is the way it is transferred. Another important part of sludge is what we call septage. Sludge is produced from central treatment facilities, but septage is produced from on-site sanitation systems. And the on-site sanitation system ranges from pit latrines to septic tanks to small anaerobic treatment units. So the septage in Egypt, which is produced from about 50% of the population in rural areas, our study revealed that we don't have good information about the quantity or quality of the septage which is produced from the on-site sanitation. The reason is that these systems are built by the people not under the supervision of any official organization. So we don't know what they are doing. We don't know whether these on-site systems are leaking to the groundwater or the groundwater is adding to these units water. So more studies has to be carried out. The proposed technology, or one of the technologies, is anaerobic digestion to produce biogas, which can be used, and these systems do exist under the supervision of some of the donors in rural areas, and also we have two types of anaerobic units, the Indian model and the Chinese model. So from our study, we can say that fecal sludge is our weakness point in Egypt. The reason is that a variety of on-site sanitation technologies are implemented. The difficulty to measure the infiltration and exfiltration in the systems in use, the way of emptying and disposal bring a high variability in the septage characteristics. So intensive surveys and studies have to be carried out. Also, we have to adapt and transfer the technologies from other countries with similar situations. The recommendation to construction of central sludge treatment facilities for sludge and septage. This means that we collect the septage from the different systems or from the different treatment facilities and treat it in a central sludge treatment unit. We have to enforce the existing rules and regulations, also to update the regulations, improve and update the quality of data on rural sanitation, encourage investors, private investors, to convert sludge into fertilizer and renewable energy, control the release of toxic chemicals from industrial sources into the sewer network to avoid accumulation of such chemicals into the sludge to optimize its use, develop sustainable technology for sludge treatment and disposal, develop appropriate systems for treating septage, integrating rural sanitation in watershed management, organization of training courses for the operators, because I think that this there is a lack of knowledge in this area. Before closing, I would like to thank my colleagues who participated in the preparation of the roadmap, Dr. Rafat, Dr. Inat, Dr. Said Ismail, Dr. Muhammad Mahmoud, last but not least, Mrs. Manal Tharwat El-Aab. Thank you.
Thank you very much, Dr. Fatma, for highlighting the current situation of sludge and septage, and what's the plan so to control and manage the sludge in sustainable way. At the end of these three presentations of roadmaps, we have received some questions from the participants. We have a question addressed to Dr. Safwat from Engineer Nuran Marsafi. She's asking about where we stand now. So Dr. Safwat, you have the floor to answer the question raised to you.
Yes.
The microphone now. Can the microphone be available for me? Do you hear me? Okay. Well, thank you for the question. The question is very important. Actually, the future of availability of drainage water for reuse is dependent on two factors, the quantity and the quality. Let me say that drainage water is the most readily water for using to close the gap, since we have agriculture and irrigation. Drains are receiving the excess water, and it could be considered the cheapest among all non-conventional water for reuse. Because of the limitation of time, I did not touch upon the monitoring of drainage water in the drains. The Ministry of Water and Water Resources and Irrigation since 1970 developed one of the most sophisticated drainage network on monitoring drainage water on all drains in Egypt, and it was successful to identify the quantity and the quality along the network. This was behind where some drains were excluded from the plan and where it can be used. Mixing is according to criteria set up by research and is used accordingly. Now, answering your question, as far as irrigation exists, we have drainage water which is available in the drains. Any future development in improving the irrigation efficiency, the quantity will decrease. However, we are looking into those drains which are not used so far, and by where there's some pollution, and until we see the project for rural sanitation and urban sanitation which are in progress, and there is a very well done plan for covering all the urban and rural areas with drainage, there will be improvement in the drainage. So actually there is interconnection with different factors which determine the future. Maybe the government is moving in some areas faster even than was expected in the plan by, as I said, establishing the giant treatment plant for drainage water in Mahsama, on the Mahsama drain, to provide drainage water across Suez Canal to irrigated area in Sinai, and Bahr al-Bahr, which one is the largest agricultural drain in the Nile Delta. This will make them available. Meanwhile, the Department of the Ministry of Water Resources and Irrigation, through its also research institutes, are using some cost-effective technology, like using the natural and biological means in the drains, using natural plants to improve the quality of drainage water. This has been implemented in a number of areas. It is not, we cannot give a sharp answer to your question, but there is progress along the different fronts of the factors influencing the availability of drainage water, which can be with, in one areas increase, in some areas decrease, but the resultant is so far drainage stands as the biggest amount of non-conventional water available for reuse in agriculture.
Thank you, Dr. Safwat. We have also another question or a general remark. Someone is asking, can we download these presentations? And I just checked with the organizers. Yes, all the presentations will be available on the site of Cairo Water Week at the end of the week. They collect all the presentations of all the presenters, and it will be available on the site. These are so far the questions that we have received, but if any of the panelists have questions to his colleague, go ahead and you can ask your question. So whoever has question, please do, from Dr. Safar, Dr. Fatma, Dr. Rafa, Dr. Hossein.
Well, I have a question for Dr. Hussam Shawi. Actually, you presented very optimistic picture for expansion in desalination, and which actually is refreshing to know that we are moving along the right direction. But I would like to ask you, is there on the national scale a master plan prioritizing areas where desalination plants will be implemented during the next 5-10 years, and how far they are connected also with the National Water Resource Plan that developed by MWRI in coordination with all concerned ministers?
Thank you, Dr. Safwat. Actually, yes, there is a master plan for the implementation of this desalination plant, as I present in my presentation. And for example, in Matruh, there is a master plan of having more than 900,000 cubic meter per day by the year of 2037. In Red Sea, 400,000 cubic meter per day. North Sinai for 370,000 cubic meter per day, South Sinai. So the master plan is not only an estimation for what we need, but also it contains a precise place where this desalination plant will be implemented. There is also a lot of concern about the operation maintenance of this desalination plant. As I mentioned, there is a lot of entities, more than one entity, concerning the operation and maintenance of desalination plant. For example, in the new communities, the desalination plant belong to the urban community. In the Red Sea, some desalination plants are operated by the water and wastewater company in the Red Sea, and some plants are operated by the armed forces. So yes, there is a precise place, there is a precise quantity, there is a precise also identification of the power consumption of this desalination plant. And as I mentioned, the power consumption and the power needs are going parallel with the desalination plant's needs, because the huge number of the cubic meter of this desalinated water are also needs a huge number of kilowatt hour of power. So there is a precise numbers, and also there is a future work of DPP with the private sector on running the desalination plants. So the plan are precise, and there is a precise details of everything related to the desalination plant.
Thank you. Dr. Hossein, there is another question addressed to you, asking about, are floating desalination common in Egypt, and if so, which renewable energy are they based on?
Yes, actually, this we are working on a new trend of the desalination plants. which is called a floating desalination plant. This type of plant actually is needed a lot in Egypt because, for example, in the north coast, there's a lot of resorts which is only work in a precise time of the year. So without the need of constructing a desalination plant in every location, a floating desalination plant can be a good solution in this kind of spots. Running with renewable energy would be a sufficient or also a good solution for such kind of desalination plant because of the environmental issues. And so we are working on a project of designing and implementing a desalination plant, a floating desalination plant with 6 cubic meter per day of desalinated water, but also we are working of designing 10,000 cubic meter per day a floating desalination plant running with PV and also hybrid PV and wind turbine to be deployed in Jabal Zayt, Red Sea.
Thank you, Dr. Hassan. I think by this, to the end of our session, I would like to thank all the participants who participated with us in this session. I would like also to thank our speakers. They highlighted the output of the roadmaps prepared by the Water and Irrigation Research Council. Thank you very much for your informative presentation about those roadmaps. I would like also to thank the members of the Water and Irrigation Research Council who participated in drafting those roadmaps. And not to forget, of course, to thank the Academy of Scientific Research and Technology for sponsoring this session. And at the end also, I don't want to forget to thank the IT team of Cairo Water Week who helped us a lot in putting the presentations and the session in time and place properly. Thank you all, and I'd like to see you soon in another event. Thank you.
Thank you.